All right, so let's go through the examples here after you've gotten your book filled in with your trig ratios, right? Be able to come up with the ratios, and these are a bit more generic where we don't have the side lengths, but we can go ahead and write them out with just the variables. So sine of A, right? So you're standing here at angle A. Sine is opposite over the hypotenuse, so the opposite side is going to be A. The hypotenuse is going to be, of course, C. So your ratio would be A over C, right? Cosine of A, I'm standing here on A again. Cosine is adjacent over hypotenuse. So the adjacent is going to be B, and the hypotenuse is C, so it's going to be B over C, right? The adjacent is next to the angle, and of course the hypotenuse is always the hypotenuse, right? Pay attention to number 3, where they switch the angles. Tangent of B, right? Tangent of B is right here. Tangent is opposite over adjacent, so we want to go B over A. Right? Sine of angle J. Here's angle J. Sine is opposite over hypotenuse, so that's going to give you, right, J over L. Look at cosine of K. Stand here at K. Adjacent over hypotenuse gives you J over L again. One thing that you'll start to pick up is that the sine of one acute angle is the same as the cosine of the other acute angle. That'll make a lot of sense if you sit and think about what those ratios are. And then tangent of angle K. We come back here to K. Tangent is opposite over adjacent, so you get K over J. Okay, so hopefully that makes enough sense. And in your book, there's an example, a couple of examples of this, and so I know we want to just practice this, but I'll do one and then let you do number 2 here. Okay, so again, we want to write these trig ratios from the angle that we know. And number 1, we know that angle there, it's 59 degrees. And then we want to use the trig ratio that uses a side that we know with a side that we don't. We only want one variable in our little trig equation, right? So from this angle, we know the opposite, we don't know the adjacent, and so that's going to be tangent. So we're going to use tangent of 59 and make that equal to 17 over x. And when this happens, this is a proportion that we can cross multiply and solve, or we can use a shortcut. If x is down low in the fraction, then we're going to switch the x in the tangent 59. That's basically what ends up happening. And then when you divide 17 by the tangent of 59, and your calculator is in the right mode, you should get 10.2 for that length of that side. Okay? If it's not in the right mode, then you got to come talk to me and we'll figure out how to put it in the right mode. Okay, so try setting up number 2. Stop the video, start it back up, and check your work. Okay, we come back here to the angle at angle is 26 degrees. We know the opposite, we don't know the adjacent, so again that's going to be tangent. So tangent of 26 is going to be equal to 7 over x. Again, since x is down low, we're going to switch the 7 and the tangent of 26. Divide those out. You get 14.35 or 14.4. Round to the nearest 10. Okay? Make sense? I do hope. Okay, number 3 is a story problem. There's a lot of words, but we can draw this out. Draw a picture, it helps, right? It says find the length of the hypotenuse, which means that we must have a right angle. Find the length of the hypotenuse, that's the hypotenuse. One acute angle is 20 degrees, and the side opposite the angle, which is going to be this side, is 410. And now we want to go find x. Well, from that angle of 20 degrees, we know the opposite. We want to find the hypotenuse. That's sine. So we use sine of 20 equals 410 over x. And now, again, since x is down low, we want to switch these. If x is high, we multiply, right? But now we're going to divide these out. And it turns out the hypotenuse is 1,190 feet, 98.8 feet. Okay? All right. Now, to go along with this, we can talk about what are called angles of elevation and depression. An angle of depression is if an object is lower than a viewer, someone who's trying to look at an object. If it's lower than you are, then you have to look down to see it, right? So that's your angle of depression. So kind of like this. If you're standing on a wall or a building and you want to look down at a car, right? So this is going to be your angle of depression. It's your eyesight, your normal eye line, which would be straight across. And then if you have to look down to see something, that's going to be your angle of depression. So this is the angle that we're talking about. And as you see, your straight across eye line, and then to get to the car here, you got to go straight down. So that creates your right angle. That's where you're going to find your right angle. And then you've got a right triangle. You'll have an angle, or you might want to find an angle, but you'll have an angle there, and then you can use your trig ratios to find whatever distances you need to from you to the car. Okay? So let's find some examples here. So this says that you're skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. About how far do you ski down the hill, right? So, in other words, the actual distance from where you are down to the bottom of the hill, we want to know what that distance is. We know the elevation of the hill is 1,200 feet, so the height. So from the bottom of the hill to the top of the hill is 1,200 feet. If you're standing here at the top of the hill and you have to look down to see the bottom of the hill, which you do, then you've got an angle of depression, and so that angle is going to be 21 degrees. So this is how this would set up. We go to our trig ratios, right? This angle is 21 degrees. We know the opposite side. We want to find the adjacent. So that is sine. So we can go sine of 21 degrees equals 1,200 over x. Switch this, because x is down low. We switch this. Take 1,200 and divide it by sine of 21. And the distance from where you are to the bottom of the hill is actually 3,348.5 feet. Okay? All right? It's kind of the same thing. Give you some practice on drawing this. You're skiing on a mountain with an altitude of 1,400 feet. The angle of depression is 27 degrees. About how far do you ski down the mountain? You want to draw this out. So I'll give you a second to try to do that, and then come up with your trig ratio to answer the question. Right? So I hope it looks something like this. Here's your mountain. Here you are. Your angle of depression is 27 degrees. Since the altitude of the mountain is 1,400 feet, we want to find the actual distance from you down to the bottom of the hill. So again, opposite over hypotenuse gets us using sine. So sine 27 be 1,400 over x. Since x is down low, we're going to switch these two. Take 1,400 divided by sine of 27. And so the actual distance is 3,083.8 feet. Okay? All right. Here's the ones a little bit different. See if you can't draw the picture here. take a second, stop the video, and then start it back up and see if you got it. All right, so you're here at street level, and you're looking at the top of a building. Well, this talks about angle of elevation. So let's stop for a second and quickly define angle of elevation. Right? Angle of elevation is kind of like depression, and so instead of looking down at something, you're going to look up at something. So at this point, if you're standing here on the ground and you say you're looking at a tree, in order to look at the top of the tree, you got to take your straight across sight line and tilt your head up. So your angle of elevation would be going up. Now again, your straight ahead sight line and the height of, say, this tree is going to form that 90-degree angle. So your right triangle would be sitting like this. That's what you need in this particular example right here, right? So if you're at street level and you want to look at the top of the building, right? So this is your straight ahead sight line. You want to look at the top of the building. That's your angle of elevation, which is 37 degrees. It says you're 50 feet away from the building. About how tall is the building? Now this is going to be a little bit misleading, so we're going to find this distance right here. Now theoretically, you already know that your height, what your height is, maybe not to your eye level, but pretty close. So I'm about 6 feet tall. I'm going to use that. I'm about, close to 6'1", so I'm probably about, it's close enough, we'll use 6 feet. Let's say my eyes are 6 feet off the ground when I look. Right, so there we go. I want to find x by, from this angle 37, knowing opposite and not knowing opposite and knowing adjacent, that's tangent. So I'm going to use tangent of 37 degrees is equal to x over 50. Since x is high, I want to multiply 50 times tangent 37. 50 times tangent 37 gives you 37.7 feet, which I have to then add to the 6 feet to get the entire height of the building. So the height is actually going to be 43.7 feet. Okay? But that's your angle of elevation. Same as depression, same process, just different point of view. Okay? Try this one. Try drawing the picture and then coming up with your trig ratio and solving it. And then, like I said, you can start the video back up and check your work. Okay? Did you come up with it? There's a sailboat. And then a lighthouse. This is very generic. Right? So here's the sight line for the sailboat. Then in order to see the top of that lighthouse, you have to look up at 16 degrees. Your angle of elevation is 16 degrees. The lighthouse is 121 feet tall. How far is the sailboat from shore? So we want to find that distance right there. So again, from that angle, you know the opposite. You want to find the adjacent, so that's tangent. So we want tangent of 16, which is going to be 121 over x. Right? Since x is down low, then you want to divide 21 by the tangent of 16. And so that distance is 73.2 feet. So the sailboat is 73.23 feet from the shore. Okay? Hopefully that makes enough sense. Your homework's sitting out in Canvas. Have it done by next time.